In this video, we're going to look at a couple practice problems that involve the half-angle formulas in trigonometry. So I've written out the half-angle formula for sine, which is the sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. And now we are asked to find the sine of 15 degrees. So we can rewrite it. Sine of 15 degrees equals the sine of 30 degrees over 2. So we've rewritten it to match our formula here, and now we know that alpha is equal to 30 degrees. Now we can write out the rest of the formula here, so we're going to have plus or minus 1 minus the cosine of 30 degrees all over 2, and we know that cosine of 30 degrees is equal to the square root of 3 over 2 from the unit circle. So now let's rewrite the right hand side as plus or minus the square root of 1 minus the square root of 3 over 2 all over 2. I need to make this square root cover everything. Okay, now inside the top of this formula, I want to have like terms on top and bottom, so I'm going to multiply this 1 by 2 over 2, and then we can rewrite what's in the square root as plus or minus 2 minus the square root of 3 over 2 all over 2. And then these 2's can combine to just be 4. So we have square root of plus or minus 2 minus the square root of 3 over 4. We can simplify this a bit by rewriting what's on top and bottom as their own square roots. So let's do 2 minus square root of 3. Don't forget our plus or minus. It's going to be over the square root of 4, and the bottom can just become 2. So we have plus or minus the square root of 2 minus square root of 3 over 2. Now we need to look back at what we're trying to find, which is the sine of 15 degrees. So if we quickly draw out our quadrants here, 15 degrees is going to be up in the first quadrant. So we know that sine is going to be positive. So we can just say that this is equal to the positive version of this. So sine of 15 degrees is equal to square root of 2 minus square root of 3 over 2. For this problem, we're given a little bit more information. We're told that tangent of alpha is equal to 8 over 15, and alpha is in quadrant 3. And we need to find the cosine of alpha over 2. So first step is just to label our quadrants here, 1, 2, 3, and 4. And we're told that we're in quadrant 3, so we're down here. And then we want to draw out a triangle using our tangent value here. So tangent is opposite over adjacent. So we're just going to draw out a approximate triangle. This is going to be the opposite side, and this is going to be the adjacent side. Then we can complete the triangle with the hypotenuse. This is going to be angle alpha. And now what we're going to do is find the hypotenuse C. So up in the top right here, we'll just use Pythagorean theorem. 15 squared plus 8 squared equals C squared. This is 225 plus 64, which is 289. Square root of this, C equals 17. Now that we have all of the sides of the triangle, we can find cosine of alpha, which is equal to the adjacent side over the hypotenuse. But since we're in the third quadrant, we know that cosine is negative, so we need to put a negative sign here. Now we can write out the half angle formula for cosine. Over 2 is equal to plus or minus the square root of 1 plus cosine of alpha over 2. And we have our cosine of alpha right here, so we can just plug it in. And that's going to give us plus or minus the square root of 1 plus a negative 15 over 17. And we want like terms, actually over 2. We want like terms on top and bottom, so we're going to multiply this 1 by 17 over 17. And that's going to give us plus or minus square root of 17 minus 15 over 17 all over 2. Now we can keep simplifying this. So this is going to be square root of 2 over it's going to be 34, but we can again simplify, so take a 2 out of each of these, and we're going to be left with plus or minus the square root of 1 over 17. Okay, now I'm going to take this and we're going to move over here. We can rewrite this as the square root of 1, which is just 1 over square root of 17. And since we don't like the square root on bottom, we're going to multiply top and bottom by the square root of 17. This becomes the square root of 17 plus or minus square root of 17 all over 17. And this is pretty close to our final answer. Cosine of alpha over 2. But since we took a half angle of this alpha sine, we're ending up somewhere in the second quadrant. So we're still going to be negative. So this is going to be negative square root of 17 over 17. For this problem, we have two triangles. The first one, we are given the sides 3 and 5 and an angle theta, and we need to figure out what half of theta is. So there's a few steps to this. First, we want to figure out what the hypotenuse of our first triangle is. So we're going to do 5 squared plus 3 squared equals c squared. It's going to be 25 plus 9, 34 equals c squared. And the square root of both sides, c is going to be square root of 34. Now, we can figure out what cosine of theta is using just general ratios, which is going to be adjacent over hypotenuse. And we don't really like square roots on bottom, so we're going to multiply top and bottom by the square root of 34. Now, we can either use the half angle formula for cosine or for tangent. So we're going to use tangent this time. Tangent of theta over 2 is equal to square root of 1 minus cosine of theta over 1 plus cosine of theta. And so we have our cosine theta here, so we can just plug it in, and we're going to get square root of 1 minus 3 times square root of 34 over 34 over 1 plus 3 square root of 34 over 34. Now we're going to multiply this value by 34 over 34, and same thing for this one, so we can get some like terms. So this is going to be square root of 34 minus 3 square root of 34 over 34 all over 34 plus 3 square root of 34 over 34. And so when we divide by the fraction, these 34's cancel out, and we are left with the square root of 34 minus 3 times the square root of 34 over 34 plus 3 square root. So this is equal to, tangent of theta over 2. So this here is like some angle value. And so basically when we plug this into our calculator, we will get that this is equal to about 0.57. And if we take the arctan of that, we get that this is equal to 29.7 degrees. So the angle we were looking for in our second triangle is 29.7 degrees. Once we determined what cosine of theta was in this diagram, we could have solved this a different way using the half angle formula for cosine. So we'll write that out. Cosine of theta over 2 is equal to the square root plus or minus square root of 1 plus cosine of theta over 2. So we'll sub this in here. It's going to equal plus or minus the square root of 1 plus 3 times the square root of 34 over 34 all over 2. So we'll multiply this one by 34 over 34 so that we have square root of 34 plus 3 square root of 34 all over 34 over 2. And we can combine the 34 and the 2 on the bottom into just 68. And if we plug this into a calculator, we'll get 0.8701 cosine of theta. Solving for theta, we'll get 29.518. To be complete, we can also solve this using the half angle formula for sine. So sine of theta over 2 is equal to plus or minus square root of 1 minus cosine of theta all over 2. So we're going to sub in our cosine value here. So it's going to be square root of plus or minus square root of 1 minus 3 square root of 34 over 34 all over 2. Multiplying that 1 by 34 over 34 gives us 34 minus 3 square root of 34 over 34 over 2. Again, we combine the bottom into just 68. And then we can plug this into a calculator. 3 times square root of 34 this is going to be 0.4927. And if we take the arc sine of this, we get 29.5181 degrees.